The servers hum. A silent, invisible war wages within their racks, not for data, but for pure, unadulterated power. Every query, every generative image, every line of text birthed by artificial intelligence demands an insatiable hunger for compute. It's a resource so critical, so scarce, that it's become the hidden choke point in humanity's greatest technological race. The future of AI isn't just about groundbreaking algorithms. It's about having enough digital muscle to run them. For years, one company has stood as the undisputed titan of this digital muscle, NVIDIA. Their specialized graphics processing units, or GPUs, became the backbone of modern AI development. But this dominance, while a testament to their engineering prowess, created a critical dependency. For every OpenAI, every Google, every ambitious AI startup, access to these crucial chips meant navigating long lead times, immense costs, and the strategic vulnerability of relying on a single major supplier. The price of progress started climbing exponentially, threatening to slow innovation for even the best-funded labs. It became clear that to truly control their destiny, these tech giants couldn't simply buy off the shelf. They had to build. Google led the charge with its custom tensor processing units, tailored specifically for its machine learning workloads. Amazon followed with Inferentia and Trainium. Meta joined the fray, all seeking to free themselves from the compute bottleneck, optimize performance, and drastically reduce operational costs. It wasn't just about saving money. It was about unlocking entirely new capabilities. Which brings us to OpenAI. The rumors have been persistent, quietly circulating through the tech world. OpenAI, the company behind some of the most advanced AI models, is developing its own custom silicon, potentially codenamed Jalapeño. Most people might think building a custom chip is just about making AI faster. But that's where the deeper truth lies. It's about fundamentally reshaping how AI works, gaining an unprecedented level of control, and ultimately, defining its future direction. Think of a Formula One team. They don't just buy an off-the-shelf engine. They custom-build every component, specifically engineering it for maximum performance on their precise track and strategy. OpenAI seeks that same bespoke control, optimizing every transistor for the unique demands of their cutting-edge models. However, designing and manufacturing a custom chip is a colossal undertaking. It demands billions of dollars in investment, a specialized workforce of engineers, and years of dedicated research and development. The intricacies of semiconductor physics, the challenges of mass production, and the constant threat of manufacturing defects mean that even with vast resources, success is far from guaranteed. Companies like Intel have spent decades perfecting this art. For OpenAI, a software-first company, this pivot into hardware represents a strategic gamble of epic proportions, weighing the long-term promise of independence against the immediate, tangible risks. If Jalapeño proves successful, it could fundamentally reshape the AI landscape. NVIDIA, while still a powerhouse, would face a formidable competitor that builds hardware specifically for its own, wildly popular AI models. It's a move that echoes Google's TPUs, but with a crucial difference. Google's chips primarily power its own internal services and infrastructure, whereas OpenAI is building a foundational model that others use, potentially offering their optimized hardware as a service. This shift could trigger an even more intense scramble among other AI developers to create their own custom silicon, leading to an entirely new competitive dynamic driven by hardware innovation. Beyond the immediate competitive implications, custom chips like Jalapeño promise a future where hardware and software are designed in perfect harmony. This tight coupling allows for unprecedented efficiency, potentially enabling AI models that are faster, more powerful, and crucially, consume less energy. It means unlocking new computational paradigms, pushing the boundaries of what AI can achieve. Such control also affects the economic distribution of AI power, potentially making advanced AI more accessible or, conversely, consolidating it among those who can afford bespoke silicon. The ripple effects will touch everything from scientific research to artistic creation. The race for AI power isn't just about faster calculations or cheaper operations. It's a strategic battle for control over the very infrastructure that defines the future of artificial intelligence. Companies willing to invest billions into custom silicon are not just building chips. They are laying down the tracks upon which the next generation of AI will run. Whether Jalapeño becomes a legendary success or a cautionary tale, OpenAI's rumored venture into custom hardware signals a profound truth. In the compute wars, he who controls the silicon holds the keys to AI's ultimate destiny. The path ahead is uncertain, but the implications are profound for us all.